In the first part of the video, we learned the basic theory of diodes, and multimeter diode testing. To understand the diode operation in depth, it is time to measure the static characteristic curve in the laboratory. The test circuit, for the forward bias section of the curve, is a half-wave rectifier. The test circuit is modified by inserting an auxiliary diode in order to measure the reverse bias section. The auxiliary diode cuts off the positive half cycles of the supply voltage. Thus, the high power dissipation in the resistor is zeroing. The diodes 1N4148, N4001, and N5402 will be tested. Let's go to the lab. First, the forward bias section of the curve will be measured. We need a power transformer with multiple taps, an oscilloscope, and an appropriate resistor for each diode. The transformer supplies a sinusoidal voltage of 5 volts RMS and frequency 50 Hz from the grid. In the 1N4148 diode, the resistor is selected to be 10 ohm, to obtain a peak current of 0.6 amperes. The power consumption of the resistor is 0.8 watt. The first channel of the oscilloscope measures the voltage across the diode. The second channel inversely measures the resistor voltage. Channel 2 is inverted, to indirectly measure the diode current. By selecting the XY mode, the instrument displays the forward portion of the characteristic curve. In the 1N4001 diode, the resistor is selected to be 2 ohm, to obtain a peak current of 3 amperes. The power consumption of the resistor is 4 watt. The oscilloscope displays the voltage across the diode on channel 1 and the current on channel 2. By selecting the XY mode, the forward portion of the characteristic curve is displayed. In the 1N5402 diode, the resistor is selected to be 1 ohm, to obtain a peak current of 6 amperes. The power consumption of the resistor is 8 watt. The oscilloscope displays the voltage across the diode on channel 1 and the current on channel 2. By selecting the XY mode, the forward portion of the characteristic curve is displayed. The reverse bias section of the characteristic curve, beyond the breakdown voltage, is the most surprising. The diode is usually destroyed when the supply voltage exceeds the breakdown value. The resistor is chosen to be 1 kilo ohm for all diodes. The multi-tap transformer provides a maximum voltage of 270 volts RMS, or 380 volts peak. However, the breakdown voltage of 1N4001 and 1N5402 diodes is even higher. It was an unexpected result, because the diodes in question, according to the datasheets, withstand a much lower voltage, at least 50 volts and 200 volts, correspondingly. If the supply voltage significantly exceeds the breakdown value, the diode is destroyed. So, the 1N4148 diode is supplied with variable voltage from the variac. The breakdown voltage is about 160 volts. At higher voltages, the diode holds the breakdown voltage and conducts current, according to formula. After a few seconds, the diode is short-circuited and destroyed.